Good morning, Tehmina Khan is here, and in this video I will explain or continue the topic of kinematic. This is video number 4, and in this video I have picked up the past paper questions from kinematic, which is a topic of A-level mathematics CII syllabus. And now you will sketch the graph from the description given to you, and then you will answer the questions. So before I begin, you can see on the top my blog address, TKMaths.blogspot.com. You can find the link of my all videos over here. I have also made the playlist so you can refer that as well. So let's look at this question. It is from June 18, paper variant 4.1, question 5. This is about a sprinter race of 200 meter, and the total time of race is 20 seconds. I'm just telling you the main points of the question, right? And he starts from rest, and for 6 seconds move with uniform velocity, reaches to a speed of 20 meter per second. Then he maintains this speed for the next 10 seconds and then start uniform deceleration and finishes the race at v meter per second. So if I show you this whole description on trajectory, it will be something like this, that he starts at 0 second, ends at 20 second. For 6 seconds he is accelerating and reaches to the velocity 6 meter per second. Then at this velocity he moves with constant speed for next 10 seconds. That's why it is 16. Total 16 seconds have passed. And then he will decelerate till 20 seconds and ends the race with certain velocity. Now please remember, whenever you draw this type of trajectory, it's always easy to understand the question. So better visualization for yourself. That's all, not a requirement. Okay. So now the first part of the question is saying the distance traveled by the spinner in 16 seconds. So let's see this part and then we will read the rest of the question. So now here I have drawn this sketch of velocity time graph, right? And it is for me to understand better. I will see later, is it the requirement of the question or not. If you do something for yourself, it's fine, there's no harm, right? So now for first 16 seconds I have to find out the distance. So what is this shape? This shape is a trapezium. This line and this line is parallel, and this is the distance between parallel line. So in the trapezium formula, which is half into height into sum of parallel sides, my height will be 12, which I am getting from here, and parallel sides are 16 and 10. So this is why I am writing it like this. Can show you from graph also, right? So I have calculated that the distance covered in 16 seconds is 156 meter. So the next part of the question was saying, sketch a displacement time graph for the 20 seconds, right? So now you have to change this graph into displacement time graph. Now the question is not saying draw velocity time graph or sketch velocity time graph. I did it so for myself so that it is easy to see how many segments are there and how it is changed. So basically there are 3: accelerating, constant, decelerating. And we have seen in the previous video that acceleration is how it is expressed. Do you remember? Like this in the displacement time graph. And then constant is represented, constant speed, constant velocity, with a straight line. And then deceleration is represented by this type of curve, right? So let's see here. But in the displacement time graph, what is missing here right now? The distance is covered in each sector. So how much distance covered in 0 to 6 seconds? How much distance covered in 6 to 16 seconds? And how much distance is covered in 16 to 20 seconds? Because these distances I have to measure on the vertical axis of the displacement time graph. So to find out this distance, what will you do? You will use area of a triangle. So let's find out the distance covered in each segment, and then we will sketch the displacement time graph. Okay, so let's see here. For the first 6 seconds, it's a right angle triangle. So I found out 36 meter. And for the 6 to 16 second, it is rectangle. So 10 into 12 is 120. And the last is, because we know the total race is of 200 meter. So if I subtract these two portions from it, I get 44 meter. So now I know the 4 segments are covering 36 meter, 120 meter and 44 meter. So let's see a displacement time graph now. I'll show you up here the velocity and displacement, so it's easy for you to understand. If I will take a bigger view, then it will become very small. So let me just take a close up. So for the first 6 seconds, it is 36 meter and it was accelerating. So that's why I have shown a little curve here. Then in 6 to 16 second, it was 120 meter. So 36 plus 120 is 156. So I have drawn on 156 exactly on top of 16. And I have drawn a straight line here because it was a constant velocity. And then from 16 to 20 seconds, it was covering 44 meter. So 156 plus 44 is 200. So I have shown this shape of the curve. So you see, going up, straight and then curve down. So this is how I have drawn here. So let's see the next part of the question, which is saying find the value of V. It means the velocity at which the sprinter will finish the race. Right, so I have to find out V. So what do you think? Is it easy now? Very easy. You know why? Because you know this distance now, which is covered between 4 seconds. It was 44. So now again, this is what shape? Trapezium. This side and this side is parallel. What is the length of this side? 12. And this side is V. This is what we have to find out. And the height is the distance between parallel sides, which is 4. So let's apply the area of trapezium formula. So here it is, area of trapezium formula, and simple substituting the value, and I calculate the value of V as what it will be. Simple calculation, and you get it as 10 meter per second. So he is finishing the race at 10 meter per second. Let's see the next question. It is also a past paper question. But here I have not mentioned because the book from which I picked up did not mention the year. So this is about a train journey starting from station A going to station B. I'm just picking up important point information rather than reading the whole question, right? So going from station A to station B, and when it is moving for first 600 seconds, the acceleration was 0.025. And then it was moving with constant speed for the next 2600 seconds. You can see here. And then finally it was decelerating, and the rate of deceleration was 0.0375. Time is not given because that is the question to find out the time when it finishes the journey. So first part of the question is saying find the total time for the train to travel from A to B. And second is saying sketch the velocity time graph and find the distance AB. So I will sketch the velocity time graph first. It doesn't matter because that is helping you to answer the question. And if you do not sketch it, you sketch it as a part 2. It's perfectly fine because it is at number 2. So I am sketching it for myself so that it is easy for me to answer part 1 question. Okay, so now this is the sketch of the description I have just read, that it was accelerating for 600 seconds, then moving with constant velocity for another 2600 seconds. So 600 plus 2600 is 3200. And then for time t, for certain seconds, it was decelerating. So first part of the question is saying find out the total time. So what you will do, and the total time basically. So when you're solving a question, you need to at time work out backward. You know why? Because if I have to find time t, what is coming in my mind, that this point is t comma 0. This point is 3200 comma v, and this is the deceleration. So if somehow I can find out this v, it means I can apply the gradient formula here and calculate my t. So this is how I'm thinking backward. So it means I need to find out v first. Okay, so v is easy to find out because in this triangle this point is 0, 0. This is 600, comma v, and this is the gradient, which is the uniform acceleration. So using this formula, right, I am finding out v, which is 15 meter per second. I hope you get how I'm getting it here, because it is 600, comma v. Let me write here. Okay, so I am doing v minus 0 divided by 600 minus 0, gradient formula, and this is what I have written here. And gradient is actually representing acceleration here, because in velocity time graph the gradient is, which is your rate of change, is acceleration, right? So this is how I got v, 15. So once I got 15, now this is very simple to get here. Okay, so let's see here. So this point is 3200, comma 15. This is t, comma 0, and this is minus 0.0375. So I'm applying gradient formula here, and simply I calculate t is equals to 3600. Right? So this is how you will find out the total time. So we have a sketch, we have given the total time, and now we have to find out the total distance AB. Now I think this is very simple. Why? Let's see again through the graph. So in this graph, which is a journey of the train, this is a trapezium shape. Now this is 3600 and this is 15. So area of a trapezium, if we find out, we will get straight away the distance between station A and B. So now this side is one parallel side and this is the other. So what is this length? 3600. And what is this length? 2600. And what is the height between parallel sides? Is 15. So let's apply the area of a trapezium formula to find the distance. So here is the formula, and I hope all of you understand very easily now. So we are simply plugging in the values and finding out the total distance. So it is 46,500. Now the second part of the question is saying, let me show you the question, and so that you can visualize the problem first, and then I'll show you on the sketch. Okay, so question is saying in the last part, okay, the speed of the train is this at t seconds later after leaving A. So once journey start, the train reaches to velocity 7.5 meter per second. So what is the time in seconds over there? But here it is saying find the possible values of t. So what comes in your mind? Why it is not saying possible value rather than saying possible values? Can you think about it? Or I will show you on the graph. I mean the sketch. So here is the interpretation of the description on a sketch. Question was saying find out the time when the speed was 7.5. So of course when it was reaching to in 600 second to speed 15 meter per second, 7.5 will be somewhere below it. Just I have drawn a line here, right? So this velocity was at this time when the train was accelerating, and if I come all the way here, it was at this time when the train was decelerating. So that's why question is saying find the possible time. So you have to find out this time and you have to find out this time. So again it is very simple. Using the method of gradient formula is very simple. So I will use it in this portion and I will use it in this portion. So let's see here. The acceleration is given here. I know this point, it means I know this distance, and this I can easily find out. So this is how I have done here. I have plugged in the values and I got the time 300 seconds. So this is the first possible time. For the second possible time, either you do straight away like this and you will get this small portion because I'm using this triangle, right? So it is giving me the time 200. So I will add it into 3200, right? And otherwise, if you are not comfortable with this way direct, you can use this the whole long way. You know this point is t, 7.5. This is 3600, 0, and this is what? Because your graph is actually, let me complete it here roughly. So it is like this actually, right? That diagram I have just completed. So I'm applying gradient formula on it, and then I get the time t, which is 3400 seconds. This is how you will get 3400 seconds. So you have two times, one was 300 second and other was 3400 second when the train has velocity 7.5 meter per second. So thank you very much for watching this video. If you have learned something, please press like and subscribe button. You will get indication of my new videos. Take care. Allah Hafiz.